Hello friends, this is Gangadhar from Maths Ganga, and this is the second video related to the top 10 conceptual ideas for trigonometry regarding your mains. As I told you, you just utilize all these videos as a revision review schedule for the topics which we are discussing, right? And in particular here for the trigonometry, use these videos as a review schedule for your mains as a formula sheet to solve the problems of previous year mains and the coming mains. And now in the last video we discussed three conceptual ideas, and now I am here with the fourth conceptual idea from trigonometry. Have a look at this. I think you are all familiar with this, but now here just I am revising this, how it is utilized to solve the problems, right? Look at that. This conceptual idea tells us how to calculate the values of trigonometric ratios for the angles like 90 plus r minus theta, 180 plus r minus theta. That in the sense, and so on I mentioned there, that in the sense we are going to calculate the trigonometric values for the angles of the format 9 pi by 2 plus r minus theta, not 9, n pi by 2 plus r minus theta. See, some multiple of 90 degrees plus r minus theta. So, to calculate the values of trigonometric ratios for such angles from the known sin theta, cos theta and tan theta, how to do that, that's what I am going to discuss here in this fourth conceptual idea. To find those, we need to follow three simple steps. In the first step, you just express the angle in any of these formats. Something multiple of 90 plus or minus theta. And then the step 2, you just identify the angle and its quadrant. From the quadrant, you just identify either plus sign or minus sign of the trigonometric ratio. And then step 3, here if you have odd multiples of 90, then you need to change sine to the cos, cos to the sine, tan to the cot, cot to the tan, secant to the cosecant and cosecant to the secant. But whereas if it is even multiple of 90 degrees, then there is no change. Sine will be just like sine only, cos will be just like cos only. Using these three simple steps, we can calculate the values of trigonometric ratios for any angle of this format from the known angles of sin theta, cos theta and tan theta. First step, express the given angle as n into some number into 90 degrees plus or minus theta. First step gets completed. And the second step, identify the symbol either plus or minus from angle and the quadrant and the sine. And the third step, if it is odd multiples of 90, there is a change, sine to cos, cos to sine, like that. If it is even multiple of 90, then there is no such change. The trigonometric ratio just be like that only. And now I have an example in B subbit of this fourth conceptual idea. There I am going to calculate the value of sine 210 degrees. Right? Just go through this. Sine 210 degrees. See, this 210 degrees can be expressed in two ways. Right? In one way, 90 degrees into 3 minus 60. That means 270 minus 60. In the other way, 90 degrees into 2 plus 30. 180 degrees plus 30. Two options I have to express in such format. Some number into 90 degrees plus or minus theta. So 270 minus 60 and 180 plus 30. Both are the format of n into 90 plus or minus theta. And now if you try to solve this, first step gets completed in expressing that 270 minus 60. In the next step, you need to identify plus or minus sign. For that, look at the angle 210 degrees. For sure, 210 degrees is the angle which is in between 180 and 270. That in the third quadrant. Where in the third quadrant, only tan and cot are positive, all other are negative. So here, sine value is negative. So minus. And here 270 is 90 into 3 odd multiples of 90. So sine will become cos. So sine of 270 minus 60 is nothing but minus cos 60 degrees. And we know that cos 60 degrees is 1 by 2. So its value is minus 1 by 2 if you move in this manner. Whereas if you move in this manner, by writing that 210 as 180 plus 30, here itself the same answer you will get. 180 plus 30, 210 is again in the third quadrant, okay? Minus n you will get minus sine of 180. 180 is even multiple of 90 degrees. So sine will be just like sine only, minus sine 30 degrees. And we know that sine 30 is 1 by 2, its value is 1 by 2. So at the end, To calculate these type of angles, we have two options, and one is that way, other is in this way. In both the ways, the value is same. I think you are all familiar with this discussion, but as a part of the conceptual ideas which are helpful to solve the questions of minds, I am revising this, right? And now with this discussion, I may conclude you some more ideas which are helpful in attempting few questions related to the minds, and those ideas I will give you as some subjects like C, D and like that. Okay, look at another subject C, where I am mentioning the negative values, negative angles for the trigonometric ratios. If I have sine of minus theta, then you will get minus sine again minus sine theta. Whereas if I have cos of minus theta, then you won't get that minus sine, it is just plus cos theta. And if you have tan of minus theta, you will get that minus tan theta. Make a note that for cos and sine, cos of minus theta and secant of minus theta, it is again plus secant theta and plus cos theta. For all the remaining, you need to get the minus sign along with this trigonometric ratio, that is CB. Whereas coming to D, if I have two angles whose summation is 90 degrees, then see, sin alpha is nothing but cos beta, whereas cos alpha is nothing but sin beta. If sum of two angles is 90 degrees, then there you will say that sine of one angle is equals to the cos of the other. Similarly, the same thing happens for tan and cot also, and secant and cosecant also. Tan of alpha is cot of beta, tan of beta is cot of alpha. Tan of one angle is the cot of the other. In similar manner, secant of one angle is the cosecant of the other. Right? Among all these things, in most of the cases, we go with these two things which are very helpful to solve many questions. If alpha plus beta is 90 degrees, sine of one angle is cos of the other. Right? And one more thing, if alpha plus beta is equals to 180 degrees, what will happen? See, if alpha plus beta is 180 degrees, see the useful two items which we need to memorize. If alpha plus beta is 180 degrees, sin alpha is equals to sin beta is one thing, whereas in the other case, cos alpha plus cos beta is equals to 0. And these two are also very helpful in solving some questions related to these angles. Right? So these are some subbits related to the fourth conceptual idea. In the C bit, what I discussed you, for the negative angles, cos is positive and all the remaining are negative. Whereas if sum of two angles is 90, sine of one angle is the cos of other, tan of one angle is the cot of other, secant of one angle is the cosecant of the other. And if sum of two angles is 180 degrees, sin alpha and sin beta are equal, whereas cos alpha plus cos beta is equals to 0. And in my point of view, this is the fourth conceptual idea which helps you to solve the questions regarding your mains. Right? And then have a look at this, and I will come up with the fifth conceptual idea. Now, look at the board. Then this is the fifth conceptual idea regarding the trigonometry, and here I included you see all the standard results which I collected from the previous year mains questions. See, these standard results are already used in solving different problems related to the previous year mains questions. So if you are perfect at this, if you memorize all these standard results, then these standard results will help you to solve the previous year mains questions as well as the coming mains also. Right? See, you just look this. Here I am just including the standard results, and if you need the proofs for all those standard results, you just go through the concepts of trigonometry, another playlist of our channel, concepts of trigonometry, where you will get a perfect class, a complete class related to the trigonometry. In those classes, I deal the complete solutions for all these standard results. Right? And now, see, you just memorize all these things. Once I revise you for you. The first one is cosecant theta plus or minus cot theta is just nothing but cot theta by 2 or tan theta by 2, depending upon the plus sign as well as minus sign. In the first three conceptual ideas, I gave you all different identities and the formulas of compound angles as well as the formulas for the multiple angles also. Using all those formulae, easily we can prove all these things, but these without proofs you need to memorize these as some standard results. Right? See, you will use these standard results in solving some other questions again. That's what, these are also just like formulas only we need to memorize. So if it is plus sign, cosecant theta plus cot theta is cot theta by 2. Cosecant theta minus cot theta is tan theta by 2. That's one you need to memorize. And another one, cot alpha minus tan alpha is equals to 2 cot 2 alpha. Have a look at this. Here the angle is alpha, right? Here the angle is alpha and there the angle is 2 alpha. Cot alpha minus tan alpha is equals to 2 cot 2 alpha. And another one is tan theta by 2 into 1 plus secant theta is equals to tan theta. Here the angle is what? Theta by 2. And here 1 plus secant theta, I have theta and then theta. Tan theta by 2 into 1 plus secant theta is equals to tan theta. Very useful one. And the next one, see, very familiar, see, very frequently used one, cos theta, theta by 2, theta by 2 square, theta by 2 power n. See, for each and every term, if you move, angle gets halved. Theta, theta by 2, theta by 2 square and theta by 2 power n. At the end, totally there are how many terms will be there? If you count, there are n plus 1 terms, right? And its result is just what? Sin theta by 2 power n into sin of theta by 2 power n. Again, I am repeating you, sin theta by 2 power n into sin of theta by 2 power n, right? Yeah. And the next one, look there. See, alpha plus beta and alpha minus beta are given. Alpha plus beta is pi by 2. Alpha minus beta is gamma. Then if you use tan, you will get a result, very useful one. Tan alpha minus tan beta is equals to 2 tan gamma. Look there once again. Sum of the angles alpha and beta is 90. Difference of the angles alpha and beta is gamma. Then tan alpha minus tan beta is what? 2 tan gamma. And one more thing. See, this is also very useful one. This type of questions you will face 2 times in the previous year mains. And now I included here as like that. A sin theta minus cos theta power 4 plus B sin theta plus cos theta square plus C sin theta sin power 6 theta plus cos power 6 theta value is just sum of these three, A plus B plus C. And it is true only if A is to B is to C is equals to 3 is to 6 is to 4. In our previous year mains, directly they gave the values of A, B, C as 3, 6 and 4. So at the end your answer is 3 plus 6 plus 4 and that is 13. Right? You need to memorize this one also. Sin theta minus cos theta power 4. Sin theta plus cos theta whole square. Sin power 6 theta plus cos power 6 theta is just equals to the sum of these coefficients if the coefficients ratio is 3 is to 6 is to 4. And at the end the simple result it is A sin x plus B cos x is equals to C. Then A cos x plus B sin x is plus or minus root of A square plus B square minus C square. This is also one of the helpful one to solve some other questions, right? And at the end, these are the standard results which helps you to solve many questions. And if you need the proofs and the discussions regarding these standard results, you need to go through the complete classes on trigonometry in our channel. They included in the playlist Concepts of Trigonometry. Right. Have a look at this and I will come up with the 6th conceptual idea. Now look at the board. The 6th conceptual idea of trigonometry for mains. See, if you look there, this conceptual idea tells us where the trigonometric functions are increasing and where the trigonometric functions are decreasing. See, where in the sense in which quadrants the trigonometric ratios are increasing and which quadrants the trigonometric ratios are decreasing. See, I think you are aware about the increasing and decreasing nature, how to discuss, right? See, if you increase the values of theta, if you increase the angle along with the increment of the angles, you need to analyze sine of those angles, cos of those angles, tan of those angles. Along with the increment of the angles theta, if their trigonometric ratio sines will increase, then we say that sine is increasing. If the angles are increasing and if the values of a trigonometric ratio are decreasing, then we say that the trigonometric ratio is decreasing in that nature, right? So along with the angles, if trigonometric ratio values are in the same side, then we say that the trigonometric ratio is increasing. If the angles are increasing and if the values of trigonometric ratio are decreasing, then we say that, see, these are increasing and these are decreasing, then we say that the trigonometric ratio is decreasing in that particular region. And the discussion of this increasing and decreasing nature of trigonometric ratio helps you to draw the graphs as well as they help you to find out the maximum and minimum of those trigonometric functions again. So look at that. In the first quadrant, sine 0 degrees is 0, we know that, and sine 90 degrees is 1. So 0 to 1. If the angles are increasing from 0 to 90, sine values are again increasing from 0 to 1. So I say that sine theta is increasing from 0 to 1. Right? And now what about cos theta? Cos 0 degrees is 1, whereas cos 90 degrees is 0. So cos theta is decreased from 1 to 0. It is decreasing from 1 to 0. And now what about tan theta? Look there, tan 0 degrees is 0 and tan 90 degrees is infinity. So tan theta is increasing from 0 to infinity along with the increment of theta. And now I have sine, cos and tan. Based on that, it is easy to write the to analyze the cosecant, secant and cot. Look there, cosecant theta is reciprocal of sine. Here sine theta is increasing and for sure cosecant theta is decreasing. Here sine theta is increasing from 0 to 1. So you need to reciprocal 0 along with 1 also. See, if you reciprocal 0, it becomes infinity, and if you reciprocal 1, it becomes 1 again. So cosecant theta here in the first quadrant is decreasing from infinity to 1. Is it right? Cosecant 0 is how much? Infinity, a very unknown large value. Cosecant 90 degrees is again 1. So if you move the angles from 0 to 90, cosecant theta values will decrease from infinity to 1. Whereas secant theta, here cos is decreasing, secant will increase from 1 to infinite. Whereas tan is increasing and cot is decreasing, here tan will increase from 0 to infinity, cot will decrease from infinity to 0. Reciprocal of 0 is infinity, reciprocal of infinity is 0. In such manner, we will discuss the increasing and decreasing nature of trigonometric ratios in all the quadrants. So I included in the 3 quadrants for sine, cos and tan. Similar to this, you just go in writing the increments and decrements for cosecant, secant and cot. And now look at the second quadrant. In second quadrant, sine theta is decreasing from 1 to 0. You just observe these values and they are enough to say whether it is decreasing or increasing. Sine 90 degrees is 1, sine 180 is 0. So 1 to 0 in the sense decrement. So sine theta is decreased from 1 to 0. Cosecant theta is decreased from 0 to minus 1. Tan theta is again increasing from minus infinity to 0. Look there, every value in this region for tan is negative. That's why you need to use the negative region. See, it is decreasing from minus infinity to 0, right? And the third quadrant, it looks like this, okay? And the fourth quadrant, it looks like this. After having this sine, cos and tan, easy for us to write for the increments and decrements for cosecant, cot and tan. See, secant, right? See, if you reciprocal 0, it becomes infinity. Depending on the region, if it is negative and if it is positive, you need to use that minus infinity or plus infinity. For suppose if you look here, what you say about cosecant theta? Here sine theta is decreasing and for sure cosecant theta is decreasing. And you need to reciprocal this minus 1, still it is minus 1. And if you reciprocal this 0, it becomes either plus infinity or minus infinity according to the region. In the fourth quadrant, cosecant is negative, so you need to use minus infinity. So cosecant theta values will decrease from minus 1 to minus infinity in fourth quadrant. See, very useful discussion all this is, okay? Have a look at all these things, right? Once again I repeat you, see, look at all those things. Sine theta is increasing function in first quadrant as well as in the fourth quadrant. And in these two quadrants, sine theta is decreasing. Whereas cos theta is increasing in third quadrant and in fourth quadrant. And in the first two quadrants, cos theta is decreasing. And if you look about tan theta is always increasing in all the four quadrants. Whereas cot theta is automatically always decreasing in all the 4 quadrants. And now at the end, using all these discussions, where the graph is increasing, where the graph is decreasing, where the function is increasing and where the function is decreasing, using all these things, it is very easy for us to draw the graphs of trigonometric functions, right? By taking angles in the x-axis, whereas trigonometric values on y-axis, you will draw the graphs for all those trigonometric functions. And it is very elementary task to memorizing the graphs also in solving many questions, not only in trigonometry but also in somewhat calculus part and some other things also. So you will get all these graphs in all the standard books. So here I am not discussing because it is a review class for the trigonometry. So if you need to learn the graphs, you just go with the complete classes of our channel or use any standard textbook, right? And now at the end, this is the discussion related to the increasing and decreasing nature of the trigonometric functions as a sixth conceptual idea. Have a look at this and I will come up with the seventh conceptual idea. And now look at the board about the seventh conceptual idea of trigonometry for mains. And this conceptual idea tells us about the ranges of the trigonometric functions as well as the maxima and minima for different trigonometric values. Just we discussed in the sixth conceptual idea where the function is increasing and where it is decreasing. From there it is very clear that always the sign values are located in between -1 and 1. For any angle of theta, the sin theta must lie in between -1 and 1. So for sure, the range of sin theta is in between -1 and 1, right? So from there it is very clear that we say that the minimum value of sin theta is -1, whereas the maximum value of sin theta is 1. So similar for sin and cos, the minimum is -1, whereas the maximum is 1. Whereas if you discuss about tan theta and cot theta, see tan theta and cot theta, the values are located, the resultant values, right, irrespective of theta. That in the sense, for different values of theta, if you observe the values of tan theta and cot theta, they always lie in between -infinity and +infinity. Whereas if you think about cosecant theta and secant theta, those values are in the region of -infinity to -1 union 1 to infinity. That in the sense, if you take different values in the place of theta, either cosecant theta or secant theta always lies either less than -1 or greater than 1, but won't lie in between -1 and 1, right? At the end, see, these three things are about the sine, cos, tan, cot, secant, cosecant. And now, if you square this trigonometric ratio, what will happen? See, now I am going to deal with sine square theta, cosecant square theta, as well as tan square theta, cot square theta, as well as cosecant square theta and secant square theta. If you square the negative values of the trigonometric ratio also becomes positive. And now from this -1 to 1 region, if you square it, it comes under 0 to 1. So for sine square theta and cos square theta, the range is 0 to 1. So if anybody asks you the minimum value of any one of these two, you say it as 0 and the maximum value is 1. Whereas for tan square theta and cot square theta, if you think, if you square this region, it comes under positive. So 0 to infinity is the range for these two trigonometric values, so tan square theta and cot square theta. The minimum is 0, where the maximum is an unknown infinite value. And for cosecant square theta and secant square theta, if you square, this negative region also becomes positive, right? Then the range is 1 to infinity. So for cosecant square theta and secant square theta, for any irrespective of theta, always the minimum is 1 and the infinity is unknown. Whereas this a sin theta plus b cos theta plus c is one of the useful one. See, for such type of trigonometric expressions, the minimum and maximum what? The maximum value is c plus root of a square plus b square, whereas the minimum is c minus root of a square plus b square. Just identify the values of a, b and c from this expression a sin theta plus b cos theta plus c. So easily you can say the minimum and maximum. Whereas if they are squares, like a cos square theta plus b cos square theta plus c, and right there. And now for this squares if included, what you say about the maximum and minimum, where the maximum value is c plus the maximum of a comma b, and the minimum value is c minus minimum of a comma b, right? First of all, you need to identify the maximum of a comma b, right? Then you need to say, you need to add that the maximum of a comma b as well as the minimum of a comma b. And now if theta is in first quadrant, then what you say about a sin theta plus b cosecant theta and a tan theta plus b cot theta, a secant theta plus b cosecant theta. Since the theta is in quadrant 1, look there all the trigonometric ratios are positive. So then there is a chance you utilize arithmetic mean greater than or equals to geometric mean. Then from there it is very clear that for all those values, the minimum value is 2 root ab, where the maximum is unknown, right? Have a look at this. This conceptual idea tells us about the maxima and minimum of some standard functions, some standard useful results, right? Whereas if you look at the questions of JEE mains, all those questions are only at this level, right? So if you memorize all these things, very helpful in solving different questions regarding your mains, right? And see, the remaining conceptual ideas I am going to discuss in the next video. So if you like this, if these videos are helpful, just like it, subscribe for it and share for your friends. Okay, I hope all these videos are very helpful in your preparation regarding the mains, right? Thank you.